Assalamualaikum and good morning. My name is Muhammad Haziq Hakimi bin Muhammad Sufyan and my metric number is S76681. Today I will be presenting on a critical aspect of marine engineering, the common operation issue encountered in marine smoke tube boiler and how can we solve them. There are 5 major enemies to boiler that we will cover today. First is scale formation, corrosion, thermal stress, oil contamination, and fire site deposit. Let's start with thermal stress. This is primarily caused by rapid heating, rising steam to fast or sudden cooling, such as introducing cool feed water. You have to remember that smoke tube boiler are rigid pressure vessels. The furnace is the hottest part and expands differently than the shell and tube. This uneven expansion leads to something called ligament cracking. The ligaments are the narrow metal strip between the tube hole. High stress causes the strip to crack, which results in dangerous leakage between the boiler parts. So how do we mitigate this? We have 3 main strategies. First, control warm-up. We must adhere to the slow firing curve. A cool boiler should take 12 to 24 hours to reach pressure to ensure uniform expansion. Second, circulation. We use hydrokinetic during startup. This forces water circulation to prevent temperature stratification, basically elimination the cool bottom, hot top condition. Third, feed water heater. We should preheat feed water to above 80 degrees Celsius using a gasket tank to minimize thermal shock at the inlet. Moving on to scale formation. Scale is formed when calcium and magnesium salt precipitate on a hot surface. The problem is the scale acts as an insulator. It has very low thermal conductivity. Because the water cannot cool the tube effectively, the metal temperature rises excessively when the metal passes its yield point. The tube butts outward due to pressure. In several cases, this leads to tube collapse, which we call bagging. To prevent this, we can use this method. First is chemical dosing. We use phosphate or polymer treatment to convert this hard salt into a soft sludge which settles at the bottom. Second is blowdown. We perform regular bottom blowdowns to remove that sludge and scum blowdown to remove surface impurities. If the scale is already served, the boiler must be taken offline for chemical acid washing or mechanical wire blushing. Next is corrosion. We generally face 3 mechanisms here. First, oxygen pitting. Dissolved oxygen attacks steel, creating deep localized hole. Second is acid corrosion. If the pH is too low, we can generalize metal tightening. Third is galvanic action. Occur between dissimilar methods. To prevent corrosion, we must control the water chemistry. First, we maintain alkali between pH 10.5 and 11.5 to preserve the protective magnetic layer. Second, we perform oxygen scavenging. We dose chemicals like hydrogen and carbohydrogen to chemically remove oxygen. Mechanically, we keep the hot wheel temperature high to encourage natural duration between the water even enter the boil. Now look at oil contamination. This is arguably more dangerous than scale. Oil forms a thin film on the water surface. This creates film boiling, which insulates the metal and prevents water contact. This causes overheating much faster than scale, leading to furnace collapse. Oil also lowers the surface tension of the water, which leads to violent foaming and priming, where water carries over into the steam. Our control measure focus on detection and response. Our first line of defense in monitoring the observation tank, we look at any visible oil sheen. If oil is detected, we minimize surface blowdown. If it's served, we must shut down and chemically decrease using an alkaline boil out. Proactively, we must regularly pressure test the heating coil in fuel tank to prevent leaks in the first place. Finally, we have fireside deposit. Incomplete combustion leaves carbon deposit, which reduce heat transfer efficiency. There are two main risks here. First is sulfuric acid corrosion. If exhaust temperature drop below the dew point 130 to 140 Celsius, surface combine with moisture to corrode the uptake. Second is uptake fire. Accumulate soot can ignite. If this burn hot enough, it can trigger a hydrogen or iron fire, effectively melting the funnel. To solve this, we need regular soot blowing, proper combustion tuning to maintain a haze grey smoke, and we must monitor stack temperature to keep them above the dew point. In summary, managing thermal stress, water, and combustion quality is essential for the safe operation of marine boiler. Thank you for your attention. That's all from me. Thank you.